Hello there, welcome to this video on graphing sine and cosine functions with some period change. Today we're going to have a lot of fun graphing sine and cosine functions, and we're going to go ahead and kind of change up the period, which has been constant up until this point. Alright, so let's go ahead and dive in. Just for a prior knowledge, go ahead, please pause this video, and I want you to do a couple of things. I want you to determine the amplitude. I would like you to determine the period, and I would like you to determine the midline of the shown function. All right, so go ahead, pause video, determine those quick things. All right, hopefully you pause the video. Here are the solutions. So first off, just identifying kind of the center of the graph, you can identify the midline. So the midline will be halfway between your maximum and your minimum. We get a midline of y is equal to 3. Now from there we can determine, okay, to our maximum and to our minimums, we're going up by 2 units, so our amplitude is 2. And then lastly, this is a sine function, so you can determine from a starting point where the cycle repeats, and that distance is pi. So we have a period of pi. Just kind of generating your prior knowledge here. All right, so today we're going to go ahead and adjust the period of our sine and cosine functions. And again, remember that the period is the length of one cycle for it to repeat. So once it starts repeating values, again, that is one period. So what we're going to do, we're going to change that. The amplitude of the function is half the distance from its max to its minimum, or the absolute value of the distance from its midline to its max or its min. The amplitude, or sorry, the midline of the sine function is the horizontal line halfway between the function's maximum and its minimum values. So again, we can kind of go ahead and see that illustrated here, but that's something that you have worked on over the past couple of lessons. So the transformations that you have learned can be applied to sine and cosine as well. If we have a horizontal stretch or compression, this is going to change our period, okay? And it will be something no longer than 2 pi radians, and that's specifically what we're going to look at today. Again, our A value, which is our amplitude, this will change the distance from our midline to our max into our minimums, okay? So that's a vertical stretch and compression, our amplitude, vertical stretch or compression. And then a vertical translation, changing up and down, where our function is centered up and down, that would affect the midline. Again, that's our k value. Y is equal to k. So note, while there can also be reflections across the x-axis and the y-axis, these do not change the values of the period or the amplitude or the equation of the midline. Okay, so those are just a couple of notes on transformations, and then here's where we're going to get to the good stuff for today. So for our sine and cosine functions, we have general functions that look like this. So g of x is equal to a times sine of 1 over b times x. And this 1 over b value, this is what's going to affect our period. Now, how we calculate period for sine and cosine functions are we take the 2 pi and we divide by this 1 over b value. Okay, and we'll illustrate this here in a second. But up until now, the coefficient of our argument has always been 1. Okay, we're going to go ahead and change that, which is we'll adjust our period. And then lastly, we have our parameter of k, which is affecting the midline. That's a vertical shift. Okay. All right, so in order to graph a sine or a cosine function with the above form, the first thing that we're going to do is determine our period, amplitude, midline, and phase shift. Phase shift we won't look at today. We'll go ahead and add that in to tomorrow in the next lesson. Now, one strategy when you're graphing these, again, is to use a scale of pi force radians. So pi fourths, that kind of is chunked down into small enough pieces that tends to work for most graphs. Okay, if it doesn't work, one strategy that you can do if you're generating a scale for a graph is to divide the period by 4. Okay, and most of our graphs will already have units, so we won't have to really encounter this. But nonetheless, this is one of the strategies. Okay, step 3, you're going to want to mark the points at the beginning and end of the period. And then from there, we'll go ahead and fill in the middle other points, right? Just cutting it in half and then cut that in half, okay? And then lastly, extend the cycle as far as needed left and right, okay? And we'll cap it off with a smooth curve. Okay, so let's go ahead and look at our first example. G of x is equal to -3 cosine of x divided by 3. All right, so the first thing I'm going to go ahead and do is I'm going to determine the period for this cosine function. Again, the period is 2 pi divided by our 1 over b value. So 2 pi divided by 1/3. That will be 2 pi multiplied times 3, right? We're dividing it by a fraction, multiplied by the reciprocal of the denominator. And so we get a period of 6 pi. So 6 pi, our cycle will repeat, okay? Our amplitude is just the absolute value of our a parameter, which in this case is -3. So our amplitude is going to be 3. And our midline is our k value, which in this instance is 0. I don't have a k value back on the end, so my midline is going to be 0. So let's go ahead. Pardon me, man, my throat. I don't have any water here. Ugh. I'll have to survive. I'll try not to try to clear my throat too much for you guys. So y is equal to 0. Here's our midline, if you can see it. Again, you don't have to graph the midline, but it tends to kind of help you out with your orientation of your graph and determining your mins and your maxes, okay? All right, so I've graphed my midline. I'm going to go ahead. I'm going to start graphing the first point of my cosine function. So just really quickly think to yourself, where does a cosine function start? That's right. It's going to start at the maximum. Okay, and in this case, though, maybe you said minimum. Maybe you were thinking ahead. We have a negative a value. Our a value is -3, which will cause a vertical reflection. So rather than starting at 0, +3, I'm going to start at 0, -3. I'm going to start at the minimum value because of our a value, and our period is 6 pi. And maybe you've kind of already seen this. Our graph only goes to the right 4 pi units. Uh-oh. So what we're going to have to do is we're going to kind of have to improvise. Thinking 6 pi ahead, okay, that's when it will repeat. Well, halfway between that, halfway to 6 pi is 3 pi. This is going to be our minimum. So what I'm going to do is I'm going to go ahead and plot the minimum. So I'm already kind of cutting that in half. There's our minimum. And then I'm going to go ahead and cut that in half. So if I cut that in half, that would be 1.5 pi, or 3 pi halves, which is here. Okay. All right. And then what I'll do is I can go ahead and do the same thing in the left direction. So I'll go to 3 pi, and that's going to be a maximum. And then at 1.5 pi, we'll be back at our midline. All right. And so I'm going to go ahead, now that I've graphed that, I'm going to just draw a smooth curve through our points. Okay, add an arrow there. And add an arrow there. Okay, and there is our function. It's important again to note, make sure it's smooth, and you should have what we kind of call inflection points here at your midline, where the kind of the concavity or the shape of your graph how it's opening up or down, kind of changes. You don't want a V-shaped graph, so don't make sure you're not just connecting a whole bunch of V's. It doesn't look like W's and M's and V's. Remember, it needs to be smooth. You got to be smooth, all right? So make sure your graph is smooth. All right, so there is our graph, -3 cosine of x divided by 3. We adjusted the period. And that one was a little bit different, a little bit wonky, which can happen. Our next example, much more clean and straightforward. So if you still feel a little uncomfortable with changing of the period, we'll go ahead and kind of iron that out right now. All right, so g of x is equal to sine of 2x minus 3. All right, so first thing, what is the period? Well, 2 pi divided by our 1 over b value, which in this case is 2. So 2 pi divided by 2 is pi. Okay, I have a much smaller period, right? Here we have a horizontal compression. The last one, it was a horizontal stretch, right? 6 pi. Wow, that's a big period, okay? For the wave to repeat. But now we're much more compressed. Okay, period is pi. Now amplitude. Our amplitude, the absolute value of our a value, which is just 1. I don't have an a parameter. Well, I do, but it's invisible. It's wearing the invisibility cloak, the Deathly Hollow. Borrowed it from Harry. Okay, midline. Y is equal to whatever our k value is, in this case, -3. Okay, so I'm shifted down 3 units. So let's go ahead and graph that midline. I'm going to try to use a thicker line so it's more visible. Okay, so here's our midline. It always reminds me of like the trails snails leave. You know, you go out in the morning, you can see where snails have been going? No? Okay, just me. All right, period, pi. Period is pi. So this is a sine function. Again, sine function's going to start where? That's right, on your midline. Okay, so I'm going to go to the midline, and I'm going to plot my first point, which is right here. Okay, and my period is pi, so I know I'm going to repeat here. Okay, and then what I'm going to go ahead and do is I'm going to cut that in half. When we cut that in half, we'll be back at our midline. And then our sine function first has a maximum. So I'm going to cut that in half, and I'm going to get my maximum. Okay, and then the next point, that would be a minimum. Remember, our amplitude is just 1, so I'm only going up 1 value. And this is what 1 cycle of our beautiful function looks like. Okay, so again, something you can do is you can just plot 1 cycle and then just repeat it all the way out. Or if you're kind of cutting your graph up into periods, which I'll go ahead and do now. This is something I do, is I kind of do this. And then I'll graph my second midline point, or my third midline point, however you look at it. And then a max, and then a min. So I'm just graphing the other cycles, extending my graph left and right. Okay, and so our graph looks like this. Okay, and I'll extend it this way with a little arrow, kind of change that concavity. And then I will extend it left. So every pi force, really, if you're looking at scale, remember we talked about scales using pi force, but if we take our period, which is pi, and then we cut that into fourths, cut it, quarter it, half and half it, I don't know, quarter it. Every pi force, we have a key point. Okay. This is really tedious, man. If you have a small period, super tedious. Okay, and let's go ahead, and draw our smooth. You gotta be smooth. Although arguably these are looking pretty sketch. All right, and there we go. All right, so that is adjusting the period, which isn't too complicated, right? You just kind of change, how far out you stretch or compress your graph. Okay. All right, remember, sine and cosine, period of 2 pi. Just take that 2 pi, divide by the coefficient, whatever the coefficient is. So here it was 2. In the last example, we divided by 1/3. So we multiplied by 3. Okay, and that just adjusts your period. Here is your first practice problem. Please go ahead, pause the video, give it a go. All right, hopefully you pause the video, and really quickly before I show you the graph, I just want to talk about the period. Again, period is 2 pi divided by your 1 over b, which in this case was 2. So this graph, cosine, will have a period of pi, just like our last example. The amplitude, 1.5, that comes from the absolute value of your a, which is a positive 1.5. And then your midline would be y equals 2. If you messed up any of that, pause the video now, go back, adjust it before I show you the solution. All right, hopefully you have fixed it. And here's what it looks like. Here is 1.5 cosine of 2x plus 2. Kind of a wonky amplitude. You go up 1.5. And then, sorry for making you draw all those waves. Woo, 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 woo. Sorry. Okay, and then we're shifted up 2. Okay, so make sure that your maximum is up 1.5 from 2, which would be a 3.5, and that your minimum's at 0.5. Here's practice problem number 2. Pause the video, you know the drill. Okay, hopefully you pause the video. Here is the solution to the period. Again, period, 2 pi divided by your 1 over b, so divided by 1/4. This actually gives us a horizontal stretch. It's kind of always the opposite. We're used to an a value being, if it's bigger than 1, it's going to stretch out. If it's smaller than 1, it's going to compress. Remember, with your horizontal factors, it's kind of the opposite. If you see a value smaller than 1/4, it's actually a horizontal stretch. So this is 2 pi multiplied times 4. 8 pi. 8 pi. Wow. Which is actually nice with our graph given. It kind of goes to 4 pi. So you get halfway. And then repeat the other half. So you could probably fit 1 cycle in this. Amplitude, absolute value of a. So our amplitude was 2. We did have a reflection. Did you catch the reflection? Okay, and then your midline was y is equal to -1. So if you need to adjust anything, please pause me now and fix that. Okay, here's the solution. All right, wow. Look at that wave, man. That's a sweet wave. It's actually not that big. Amplitude of 1. 1 what? Okay, hey, that is it. I hope you learned how to graph sine and cosine functions with adjustments to the period, and I got a little bit more practice on graphing those. All right, I'll catch you in the next video. We'll go ahead and we'll talk about phase shifts. Peace. I'm out of here.